Thank you very much. Thank you for having me, and thank you for coming with the ECIR deadline tomorrow. I'm going to get to, don't worry, the sea monsters are going to become relevant a little bit. But I want to start by just doing just a little bit of level setting. I'm sure most of you are already familiar with the many, many places where information access systems, search, recommendation, the various things that we study under rubrics of information retrieval and related communities, where we're finding products, news, media, all kinds of different things in order to help users meet some information needs. And these systems all have the interaction and overall human-computer architecture of these systems. No matter whether they are a search engine, whether it's a recommendation system in all of its many, many different forms, a conversational assistant, we can abstract them as thinking of having approximately this rough structure, which will give us some anchors for talking about the various pieces of how human impacts and how fairness become a concern. And so we've got the user who comes to the system with some kind of request. That can be implicit and or explicit. It can have a query. It can just be visiting the homepage of Netflix, which I think of as an implicit request for something I might want to watch now. The system then takes this request, goes to the repository or corpus, and finds the results that seem most likely to meet the user, the information need that's encoded in the request. And questions of fairness, questions of impact, questions of ethics can arise and do arise at every stage of this process. I'm going to be talking mostly about the response process, in part because that's where a lot of the work has happened. But there's a lot of other open questions around the system's ability, the query intent modeling, the system's ability to accurately infer the user's information need from their request. That may not be equally effective across different users or across different groups of users. The repository may have biases either in its composition, who's created material that's able to be put into it, or how are people represented in it, or in its indexing. The repository might be fine, but our indexing mechanisms are more or less effective at different aspects of the system. But with these systems, with which I think most of us here are probably quite familiar, before I start talking about the current research, I want to take us on a little historical trip. So the book North and South by Elizabeth Gaskell it's a Victorian romance. And it engages, as the better Victorian, or the Victorian authors I like better anyway, it engages deeply with a number of social questions. So North and South follows the story of a young woman who moves with her family from an agrarian community in southern England to an industrialized northern town. And when they get there, she finds herself in the middle of a labor dispute, because the industrialization of this city, which is devoted mostly to textile milling, has created a lot of new money, and created a lot of wealth, but the workers do not feel they're being treated well, and that the creation of this wealth is primarily benefiting the nouveau rich, and they are not able to participate in the wealth that is being created through the industrialization of the textile process. And there's this conflict kind of is one of the major themes throughout the book, as the mill owner and the workers dispute over their labor conditions. 130 years later, in the 1989 CBC Massey lectures, the real world of technology, Ursula Franklin raised these questions again. And her particular contribution that I lean on is re-envisioning how we think about technology. And that technology is not just the artifacts that we build, the systems, the hardware, the software, the machines, but that technology is a process. And specifically, she called it a process for organizing labor. You have a factory with an assembly line and machinery, and that provides a strict structure for how the labor in that factory is carried out. And we can think of it in terms of the information access technologies that we build are a process for organizing information, for mediating access to information. As they connect with, say, commerce, they provide structure and some organization in terms of what creators are able to sell their goods more because they show up in more search results and show up in more recommendation lists. And these technology as a process and as an artifact also has substantial impacts on people. And so Franklin was concerned with a number of questions around that. Who benefits from a technology that is being built or deployed? Who decides how it's built and whether to build it? Who is consulted in this process? Are the people who are going to have their labor organized by it consulted in this process? Are the people who are going to experience the environmental impacts consulted in this process? Who pays for it? Who controls the technology as process and the technology as artifacts? And who is it used to control? These were many of the questions that she raised, and these are many of the questions then in the information access context that underlie and motivate my work. Because the overarching theme of the work I've been engaged in the last several years and that I'm going to be sharing with you today is that information access systems are technologies with these kinds of aspects and this process dimension that Franklin talked about. They provide benefits. They may also provide harms. And there's a lot of questions around how these benefits and harms are distributed, both to different groups and within those different groups. So who's hurt by an information access system? Who benefits from it? And how do we make these, how do we ensure that these benefits are equitably and justly distributed? These are the kinds of questions that motivate my work, the kinds of questions that keep me up all night, or at least for a while. Thinking about fairness and distribution of benefits in search tools is not new. There's been a lot of activity the last decade and a half, but in their influential 1996 paper on bias in computing systems, Friedman and Nissenbaum talked about the Sabre and Apollo flight booking systems from the 80s. And these were systems that travel agents used to search for flights to sell to their customers. And these flights the search algorithm was coded to prefer an online itinerary. So an itinerary that was on the same air carrier. And often that meant that mixed carrier flight itineraries weren't until page 2 or 3 in the search results. And as this was deployed in the US, what this resulted in was the system search rankings were biased in favor of US airlines and against particularly international carriers with few US domestic flights. So because they were going to be a multi-airline itinerary. And this wound up in litigation and extensive going back and forth between the airlines and the U.S. federal government until it was finally adjusted to remove that unfairness. But thinking about fairness and who has an opportunity to show up in search results and rankings has been a question for a long time. Now, so I've talked about the underlying questions. A brief aside to the paradigm that I use to study this and why we're going to be spending time with specific examples. I don't have the citation on this slide. It's in the bibliography. So at FACT 2020, Green and Villowen had a paper called Algorithmic Realism. And in this paper, their argument was that when we're studying algorithmic systems, machine learning systems, AI systems, simple algorithms, we need to attend to the specific operation and the specific impacts of those systems as they are deployed in real settings and with real people. And they paralleled this off of a shift in legal scholarship in the late 19th century from what was called formalism, which was concerned with analyzing what the law said and the text of the law in a very philosophical manner, to legal realism, which was concerned with how the law was actually enforced, what happens in courtrooms, what happens with prosecutions. And the argument of legal realism is that we really need to understand the law through its actual effects and impacts and how it gets worked out in practice. Their argument is that we need to do the same for algorithmic systems. It's not enough to derive analytical results of what the algorithms should theoretically do. We need to study what they actually do. And this is going to be the way to really understand and advance human impact is the core of their argument. And I've been doing that before they published the paper, so it's not so much internalized as, the thing I've been doing has a name now. But algorithmic realism is the approach here. And sea monsters, the reason I bring that up and titled the talk Search Recommendation in Sea Monsters is that there is a lot of unexplored space around how do we understand the impact, both individual and social, of information access systems, and how do we measure it, how do we mitigate it, how do we define it. And medieval maps often would put sea monsters in unexplored space on the map. So we've got maps of some of this space, and we've got a high-level map of the rough contours, but there is so much that we do not know and that that we need significantly more research on in order to really advance information access that promotes just and equitable and well-informed society. So with that, let's actually get into fair information access. So there's been a lot of work the last 15, 20 years on algorithmic fairness in general, and it has produced a large number of fairness goals, metrics, constructs for pursuing these kinds of goals. You can find there are some good surveys that survey a lot of these, but there are a few important things that they have in common. And Shira Mitchell and her collaborators identified a number of these in their 2020 survey as that we're studying systems that are simultaneous, symmetric, and simultaneous, separate, and symmetric. But most of the work on algorithmic fairness has focused on systems that, first, they're classifiers. We're trying to classify high-low risk of loan default or job failure or something like that. Second, there's systems where the consequences and the decisions are individual and independent. We decide whether to give this person a loan. That doesn't affect our decision for another person. A lot of fairness work effectively assumes in the lending context the bank has infinite money to lend and wants to make all good loans. Also, there's things that are exceptions to all of these, especially this last one. There's an increasing set of things on feedback loops. But a lot of the work, especially the work that's produced the key definitions that dominate the literature, studies settings that are a one-shot process where there's just there's no iterative learning. You just have your training data, you make decisions on your test data, and that's the end. Also, most of the work, the process is independent of a user or a decision maker. And so the person using the system, it's not personalized to who's using the system. And in a lot of settings, that's what you want. It would be pretty weird if different loan officers at the same bank got different scores back from the system for the same loan applicant, because you're supposed to get the loan on the merits of your financial situation. Information access breaks every single one of these. And so some really important things that make it fair information access complex, and that mean we can't just take the fair classification, fair ML literature, and apply it directly, are first, decisions are not independent. So if we're producing a ranking, only one item gets the first rank position, that decision excludes all subsequent items from the first rank position. The second is that decisions are repeated, and this can actually compensate for the first. So we don't just produce one ranking. Users come back to the system with the same query with different queries. Every day we're making, for a given item, every day we're making millions or billions of decisions, depending on the scale of the system, about whether and where to rank that item. So you can amortize over multiple interactions. There's also multiple stakeholders. So a lot of classical fair ML work focuses just on the data subjects, say the loan applicants or people applying for a job. But in information access, we have users, we have authors and songwriters and recording artists and other people who are creating the things being recommended. Decisions are also personalized. Different users do need different results. And then finally, the outcome utility is personalized and subjective. So in a lending situation, the person will or will not pay off their loan. But a particular document might be relevant to one user and not relevant to another, something we're very familiar with in information retrieval, but it marks a significant difference because we can't treat the outcome measure, the relevance or utility or outcome measure, as an objective label from nowhere. So all of these things create a significant challenge in translating existing results to the information access setting. And with all of these complexities and with all of these different definitions, sometimes competing definitions, there are theorems showing that certain fairness definitions are mutually incompatible. It's also important to remember that there isn't an answer to bias or fairness or ethics. I get asked this sometimes, but I can't go write down a formula for here's what it means for an IR system to be fair. And it's not that we haven't worked hard enough on that yet, but it's something that's fundamentally impossible because, as Selbst argue in their Formalism Traps paper, that fairness is contextual and crucially contestable. And fairness is what philosophers call an essentially contested construct. Basically, we're never going to stop arguing about what it means to be fair. And so we can't just say, okay, we've got the definition for fairness now we can optimize it, because the fairness is this social concept that we continue to debate and contest. So this leads us to two significant moves as we do work on information fairness and information access. One is from the decisions on subjects paradigm that dominates most of the fair ML literature to this complex landscape of many dimensions, many variables, many groups and stakeholders that may benefit or be harmed. From general goals of we want to try to make the system fair to identifying and addressing specific harms. So the approach I've taken in response to the argument about contestability, the challenges of different definitions, is to focus on identifying. Let's identify one specific fairness-related harm or other harm that we want to try to mitigate, figure out how to measure and mitigate that, and then move on to the next one. And this provides a guide for navigating. If two definitions are incompatible, well, which one maps better to the specific harm that we're concerned about in this problem? And then as we've worked on multiple harms, we can start to work on their trade-offs in an inductive and an empirical way. So effective harms in a kind of empirical or in a specific harms in a particular context, both from for the reason of it helps us navigate the complexity of the space, but also it is consistent with this idea of algorithmic realism of studying actual impact in specific contexts. So to that end, the overall structure of what I'm talking about today comes from our Foundations and Trends monograph, in which we identify these dimensions, some of which I've talked about, for locating a fairness-related information access harm in the broad landscape of possible harms, and then a survey of a bunch of research in this area. So some of those dimensions are to think about and identify clearly who is being harmed. Are we concerned about harms to the consumers, the users of the system? I use the term consumer because people can use the system in the human-computer interaction sense in multiple ways. Like on eBay, I might use the system as a seller or as a buyer. And so consumers focuses on we're looking at people who are using the system in their role as consumers of information and resources. Are we concerned about harming providers? Are we concerned about harming subjects, the people or the groups that the information is about, like news articles, balancing the concerns of different regions or of rural and urban communities? On what basis are we concerned about these groups being harmed? Are we concerned about it on an individual basis? Are we concerned about them being harmed in a way that aligns with a group association, such as a minoritized identity, racial identity, gender identity? There's also some of these that arise just in information access contexts. We might want to look at, is our book recommendation system fair to new authors? Or do established authors on their third or fourth book get most of the recommendation slots? And then how are they harmed? Are they denied resources of some kind, misrepresented, unable to use the system? And answering, this is not an exhaustive list, but answering all of these questions is important in order to specify exactly what problem you're trying to solve. And so with that, I want to zoom in from this map and talk a little bit about some specific problems that we have, give you a bird's eye view of some specific problems we've been working on. So we've been thinking a bunch about provider-side fairness. Where is our system fair to the people who are making the items? And our study in Rexis 18 and UMUAI 21 looks at this in the book recommendation context, and we look across the pipeline from the corpus of books to a user's individual library or reading history to the recommendations they receive, and look across this at what fraction of books are written by women. And we found a few things. Book consumption is closer to balance than Library of Congress catalog. And we use the Library of Congress card catalog as a proxy for the corpus of books. It's a noisy proxy, but it's one that was relatively defensible. Which means that if women are underrepresented in the books cataloged in the Library of Congress, they're less underrepresented when we look at the history of what users have read and rated on their Goodreads shelves. The data we did, we used a few different data sets, Amazon reviews, Book Crossing, and Goodreads in order to do this. Collaborative filtering algorithms propagate users' tendencies. So users who read more books written by women, all the collaborative filters we looked at, they varied in how much, but all of them would recommend more books written by women to those readers. We're only making here descriptive claims about what happens. We can't, in this work, we don't reach any normative claims about what should happen. But we did try what if we force recommendation lists to be balanced? We saw very little cost in our offline effectiveness metrics. This recommendation output thing, like it's not surprising. Oh, the pattern recognizer is recognizing and repeating a pattern. But we can't assume a priori that any particular recommendation algorithm, any particular search algorithm is a perfect pattern replicator. And so studying which patterns is it replicating, which patterns is it not, with real data, allows us to understand what it's actually doing. And in some cases, the imperfection may be useful. Because if there is, say, a discriminatory pattern in our training data, but the algorithm for some reason doesn't pick that pattern up, that might be useful if our goal is not to reproduce the discriminatory pattern. So, but we got to the end of this project and realized we hadn't measured the thing we actually cared about. So we initially motivated this because we wanted to ask, so if an author from an underrepresented identity gets their first book published, is the recommender going to help them find their audience, or is it going to be another roadblock? But we measured something else, which is the representation of authors in the recommendation list, which is an interesting problem, but it doesn't really measure what we originally set out to capture about the exposure that authors get. Because search and recommendation results expose content to users, and then this has a number of follow-on benefits. It has, particularly, we identified a couple of broad categories of benefits. Direct economic benefit, where people buy the products that are listed, they click on ads, they read your article against which you're selling ads, etc. And then the indirect reputational benefits. People know your work, so they might think of you when they need to go commission a new piece of work or hire you. And so there's a lot of benefits, and we want to be able to actually measure those. So there's a number of perspectives we can take on measuring fair ranking, and this is what our Amafa's SIGIR 2022 paper was about. Fair representation, which is what I just talked about in the UMUAI paper. Fair exposure, so the opportunity for clicks or revenue. And then there's also a category that look at fair accuracy. Are the errors in the system's errors in ranking, are those fairly distributed, or is it disproportionately erroneously ranking one group above another? And these are generally motivated by trying to ensure that the utility of the system is distributed fairly across providers. And so we get these exposure metrics where if we've got a set of results and they have some relevance, and the first two results, let's say I'm looking for rabbit clip art, the first two results are equally relevant. The second one I really want filled, and a hare is not quite a rabbit. But the exposure curve in a ranked list typically falls off much more quickly than relevance. So you get this situation where the first two items have the same relevance, but the second item gets significantly less exposure. And even if you've got a situation where there might be a difference in relevance, say 2% difference, that 2% difference in relevance very quickly becomes a 50% difference in exposure, depending on exactly how users browse the list. So the solution to this that we had in our CICAM 2020 paper led by Fernando Diaz was to measure this exposure and then look for equity in the exposure. And we proposed the principle of equal expected exposure, which is the idea that for a particular information need, each item should get the class of items of the same relevance grade should get the same expected exposure. And another way I frame this is that exposure should be commensurate with relevance or utility. In another paper, Aja Biega framed this as the exposure should be proportional to the utility. We also then look at this in the context of stochastic ranking policy. So rather than just a fixed ranking or a fixed set of rankings, we think about a stochastic policy. And these naturally arise from a lot of multi-arm bandit and reinforcement learning approaches to rankers. But the idea here is if your system doesn't just compute a deterministic ranking, but rather it learns a policy and it draws the user's rankings from this policy, we can compute expected values over that ranking. And a single deterministic ranking just puts all of the probability mass on one ranking. The stochastic policies allow us also to spread around the exposure because we could switch between rankings which one of those first two rabbits gets shown first and which one gets shown second. So what we do here is we take the this is an operationalization of a class of goals called equality of opportunity. Equally relevant documents should have equal opportunity for good ranking, equal opportunity for exposure, interaction, engagement, etc. We can extend this from individual documents or individual document providers to groups by aggregating over creator groups like gender or race or ethnicity. And this gets us much closer to measuring this question that we wanted to tackle in the first place of who's benefiting on the provider side and how much. So I'm not going to get into the details of the metric. You can find it all in the paper, but basically we compute the expected exposure that each document, each group, each provider is going to get from the system's ranking policy. And then we compute an ideal policy that represents what we think an ideal ranker that was perfectly fair would do. The simple version was we looked at all rankers, or looked at the policy that assigns equal probability to every ranking that puts relevant items before irrelevant items. And then we look at the difference between the system exposure and the target exposure. So we say a system is more fair if its actual distribution of exposure is closer to this ideal from the target distribution. So then AMAFA took this metric, and a number of others, put them into a common framework, and identified that there are a few considerations in picking how you're going to measure these kinds of things, particularly whether you're looking at one ranking or a sequence of rankings, whether you're looking at individuals or groups. And also a number of metrics assume that you have fully known discrete membership in two groups. And in a lot of settings, it's useful to allow for mixed or soft membership, where you might not know the membership, where an item might belong to multiple groups, and also allowing for more than two groups, and then identifying your goal. And all of these feed into figuring out how you actually want to measure your ranking. There's some additional framings, exposure proportional to relevance. As I said, there's been work on trying to ensure recommendation chances are independent, and also looking at ranking errors. I think expected exposure most directly measures some key provider concerns around the benefit people get from recommendations and search results, but it might not always be the best one to optimize. There is also, though, some open work that's needed. Right now, the metric is very uninterpretable, and so there's work on better understanding how do we make this metric on an interpretable and comparable scale. But all of this work so far has focused on linear rankings. But grids are common, as well as other layouts, such as voice responses, streaming, etc. And so at FactRec 23, AMAFA presented some work on what happens when we go from a ranked linear list to a grid-based layout. And basically, we do see that the fairness measurement changes both with the layout from linear to grid and with the browsing model we assume about how users browse the grid. She found several browsing models from the existing literature and implemented some of them, incorporated them into a fairness metric to measure fair exposure under different assumptions of users' grid-based browsing behavior. The details of the layout, both its size and its strategy, if you have more columns than or if you don't have enough room for the columns, do you wrap or do you truncate? As well as the assumptions that you put into your browsing model, all have significant impact on fairness measurement. One of the big takeaways from this is we need good browsing models for grid-based layouts of various forms and various domains, because there isn't near as much available knowledge about that as there is in how users browse linear ranked lists displayed vertically. So from providers to consumers, consumer fairness is concerned with the set of questions around whether the users or the who are using the system to get information are being treated fairly in some sense. Remember, this is a contextual and contested concept, so I'm using it deliberately vaguely here. And we want to think both about the quantitative and qualitative aspects of their experience, and we could think about this both individually and in groups. So Soleil Perrin and I had a paper at FactRec last year where we laid out a number of these potential goals for consumer fairness. We can think about equity of utility. Different people get comparable utility or effectiveness from the system. The ease of use, say if it can't be used by children or it's hard for people to use, if they're second language learners, whether the system is representing users fairly to themselves or to others. stereotypes. A lot of different questions and goals can arise when we're thinking about making it fair to consumers. And thinking clearly about the goal and the nature is very, very important in order to design effective metrics and interventions. One way this shows up is in thinking about, say we want equity of utility. How should we actually do that? And an important thing to think about when we're defining and operationalizing a fairness-related harm is to think about the kind of benefit we're talking about. And economists have divide goods into a couple of categories. Subtractable goods people compete for. And if one person has the good, another person can't have it, or it can't have that part of it. And non-subtractable goods, people don't compete. You having one good does not affect my ability to have the same good. Information is often a non-subtractable good, because if you read a paper in the ACM Digital Library, that doesn't keep me from reading it. And so this becomes important because a subtractable good sometimes need to be zero sum. Exposure, in order to provide exposure to an underexposed group, given a fixed set of information requests and rankings, we have to take that exposure from another creator or another group. But utility on the consumer side is not that way. If we want each group of users or individual user to get comparable utility, we shouldn't, if we put it into a zero-sum solution, then we make them trade off. The key way that we start by disaggregating performance by group, measuring, say, like, do different genders, do different ages, get comparable utility, whatever our utility metric is. But a zero-sum approach to targeting it says we want to remove the difference. But the easy way to remove the difference is to decrease utility for the well-served group. Another solution that I really like was published at ICTIR a couple of years ago. And what they did was they presented a goal where you take the log of the utility for each group and then you sum those. And the most effective way to improve this metric is to improve the utility for the least well-off group. But decreasing utility for a group does not improve this metric. So this provides a way to capture this goal of equity in a way that doesn't reward an optimizer choosing a pathological solution of decreasing utility for a group. We can also think about another stakeholder, the subjects. Who is being talked about or represented in the items that are being retrieved and recommended? The Trek Fair ranking track for the last 2 years was a subject fairness track because we were concerned about the people and the places that the articles were being written about. And then we can also think about how it's being unfair. So far, I've talked entirely about distributive unfairness, and I'm going to move relatively quickly through the last pieces here, but we can also think about, and this applies to a lot of stakeholders, but there's a number of other ways we can think about how things might be unfair. So when we search for a topic, particularly this is talked about a lot in image search, who is shown in that result? And how are they shown? Also, conversely, when you search for a group, what kinds of things show up and how are they being represented back? And what roles is that group being shown occupying? So in her book, Algorithms of Oppression, Sophia Noble looks at what happens when you search for black girls or white girls. And I'll refer you to the book for the details, but it's pretty disturbing in terms of, because the search results represent back something about the search system's model of the information space as it relates to that query. And if it repeats harmful stereotypes, that reinforces negative impressions and assumptions about particular groups. And so there's a lot of reasons. So it reinforces stereotypes, and it presents an inaccurate picture of the information space or the underlying reality space. There's also ways in which the system can directly misrepresent. So AMAFA's done a little bit of work on this. We had our SIG-IR Econ paper last year was looking at gender stereotypes. And there's substantial literature in childhood development on the impact of gender stereotypes on children, especially when children are exposed to them at a young age. And it can have follow-on effects in terms of their self-image, in terms of what kind of careers or ambitions they might see themselves having, etc. And there are campaigns, a number of which are in the UK, to reduce the prevalence of stereotypes in gender stereotypes in children's experience. And so we looked at search engines reproducing these stereotypes. And so we took lists of toys from previous research and advocacy campaigns that were identified as having these social gender stereotypes, and we used them to generate queries to Amazon and Target, and then observe the query suggestions and the search results. So query suggestions, we provided a query toy for, and then we counted the number of query suggestions with gendered terms. And you'll see superhero toys for shows all boys. And so this would be then we would code this as an association of this toy category with boys. And we found that query suggestions did have gender alignment with toys in a systematic way that also correlated with these previously documented stereotypes from the existing research. We also then looked at search results. So we gave 3 queries. We took the toy, we searched toy for kids, toy for boys, toy for girls. We then compared the gendered results with the neutral result, and we considered it to be a gender alignment or reflective of a stereotype if the neutral result was more similar to one gender than another in terms of the actual product listings that were being returned in the search results. And again, we found the gender stereotypes propagate. This is really, really early work. It's kind of the simplest measurement we could try to do that seemed sensible. There's a lot more work to do about how do we operationalize, how do we measure the idea of gender stereotypes in search results. How do we decide when it should be a concern and when it shouldn't, etc.? Our goal here was to start that conversation and provide some initial data. We also had a paper at Cheer this year on, broadly, how should we think about using gender in information retrieval systems? And argue that often we probably shouldn't. And when we do, that we document some best practices, such as using self-identification, using inclusive categories, documenting very thoroughly what has been done, not assuming binaries. And then we also provide a systematic literature review of what's been done in the last 5 years of IR literature with gender. So all of that to get towards wrapping up. The key things to do in working on this space are to start by clearly identifying and scoping the problem that we're trying to work on. I've tried to do that throughout my work. It's kind of gotten better over time because some of my early work, we didn't know exactly what to do with problem definition. It's also important to clearly identify and document the actual fairness goal and its underlying moral, legal, ethical, economic, etc. motivation so that you have an idea of what problem you're actually trying to solve, and we can have a more robust conversation about where this thing would be applicable and when it wouldn't. Target specific harms and then kind of build up from there for generality. Be clear and thorough about limitations, and there's so much work to do to expand the map. So where do we go find more sea monsters? Everywhere, but there's been a lot of work on distributions of utility and value. Often it's been one group at a time, but there's been less work on representation, multiple groups, the complexities of dealing with multiple users. We kind of do some crude averaging right now. How to appropriately collect and share this data. A lot of problems there on measuring. Also, we haven't, there's not been very much work across the pipeline, mostly just seeing the ranker as a monolithic system. But what if you have a multi-stage pipeline with candidate selection, ranking, and so on? There was a paper at FactRec last year from the Twitter folks about that, but there hasn't been much work on, say, if you make your candidate selection fair, what impact does that have on your ranker? Actual tools for model owners to solve these problems. I don't have time to get into the details on some philosophical and legal questions that I'm trying to think about. And then how do we involve the people who are affected in the process of evaluating the system? There's also the last question I want to leave you with is fairness the goal? I've done a lot of work on fairness. But is fairness the goal, or is it a means to a broader goal of producing a just and equitable society? This is something I've been thinking more about the last few years and how to actually better articulate this. There are questions that come up in terms of being fair to people who are working to harm society through information. Should the system be fair to them? No easy answers here. So thank you again for being here and for hosting me. A bunch of this work was funded by an NSF grant, and my wonderful students and collaborators for working on this work, and I would be happy to take any questions. Thank you for your interest in my work and for taking the time to watch this video. If you'd like to read more about my research, you can find it at my website, along with my open source research software and information on my teaching, and a lot more about my academic work and output. Thank you, and hopefully see you in another video.